This lesson's on double integrals where we are going to be switching the order of integration. So what I have here is the integral is x goes from 0 to 1. Integral is y goes from x to 1 of sine y squared dy dx. Normally speaking, the first thing we would do we would look at the inner integral. And the problem with that is I have no idea what the integral of sine y squared is. You could approximate it using a Taylor series, but we want to avoid that kind of thing here. So one strategy that may work if you come across an integral you can't do is to switch the order of integration. So what do we have here? Y equals x is our southern boundary. Y equals 1 is our northern boundary. So let's visualize. So starting with our southern boundary is at y equals x. We want to move up from that. So starting at y equals x, and the northern boundary is y equals 1. So let's zoom in on that. And what is x ranging from here? X is ranging from 0 to 1. So what is my region of interest here? What do I want? X is ranging from 0 to 1, starting here, ending there. So there's our region. Again, southern boundary, y equals x. Northern boundary, y equals 1. X ranges from 0 to 1. I want to change the order of integration. What will that be? So instead of going south to north, I want to go west to east. So I need to think about what these fences would be. The fence on the west is the y-axis. That's x equals 0. This was y equals x or x equals y. So if I'm going west to east, my inner integral would be what? X starts at 0 and it ends at y. And then what are we going to do? Then look at all of my possible values for y. But this point here was just the point 1, 1. So the lowest y value I see is 0. And the highest y value I see is 1. So I've changed this from a dy dx. I've switched the order. It is now a dx dy integral. Now, the good news is I'm first integrating with respect to x, so I don't have to worry about the integral of sine y squared right away. But that's how I switch the order. So let's go ahead and look at that and try to evaluate that double integral. The first thing I do is I work on the inner integral, which is the integral as x goes from 0 to y, sine y squared dx. Now, the thing here is x is perceived as the variable, so any function of y is perceived as a constant. So that can be moved out in front. Sine y squared, then I have the integral as x goes from 0 to y of dx, or 1 dx, which would give me sine y squared. The antiderivative of 1 is just x, as x ranges from 0 to y. That gives me y sine y squared minus 0 sine y squared. So that my inner integral here is y sine y squared, which is a much improved function to work with. So substituting that in for the inner integral, now to actually do my integral, we have the integral is y goes from 0 to 1 of y sine y squared dy. So how are we going to do this? That's going to require a u substitution. So let's quickly remind ourselves of that process. So u is going to equal y squared. So du dy is 2y. So du divided by 2y equals dy. We also need to keep in mind, though, that I better change my endpoints, although it just so happens here it's not going to be crucial. Because if y is 0, what is u? U is 0 squared. If y is 1, what is u? U is 1 squared, so it's actually not going to change. Y is here. Sine y squared is sine u. Dy is du over 2y. Again, that's 1 squared, not 12. Just clarify the notation. So then what do I get here? I get I is, let's pull the 1/2 out in front. Integral as u goes from 0 to 1. You'll notice the y's divide out. Y's divide out. Boom, boom. And I have the integral from 0 to 1 of sine u du. I prefer to change the endpoints as we go through this. The antiderivative of sine u is negative cos u. So my antiderivative is negative 1/2 cos u, evaluated as u goes from 0 to 1. What will that be? Integral will be negative 1/2 cos 1 minus negative 1/2 cos 0, which will be negative 1/2 cos 1 plus 1/2 cos 0, but cos 0 is just 1 plus 1/2. So let's write it this way, 1/2 minus 1/2 cosine of 1. And what is that as an approximation, just so we can see? About 0.2298. Now let's check with technology to see if our answer is in line. So here was our original question. We think it's about 0.2298. Let's jump to technology and see if that's what we get. So here's what I get on the double integral calculator. Our function was sine of y squared, the dy dx order. X ranged from 0 to 1. Y ranged from x to 1. We could not do it in that order. We had to switch it to get it. And what does Wolfram Alpha say? We have 0.2298, so I feel pretty good about that. It happens to be sine squared of 1/2. Curious how it did it. My guess is it did something equivalent to a Taylor series, or indeed it probably switched the order.